Hey everyone, welcome back. I hope you guys had a nice weekend. Today we are going to talk about different types of productive resources as well as looking at what a production possibilities curve is. So as a brief review of what we looked at last week, we talked about the fundamental economic problem known as scarcity. Now remember, there are limited resources, limited money that people have. However, our wants are unlimited. So that leads to what's known as scarcity. And scarcity forces us to make choices and trade-offs based on our perceived opportunity costs. So when it comes to scarcity, we then have to decide how to best allocate our resources to meet our needs, to satisfy our wants. The 7 different types of allocation methods are listed below. We went over those last week. So, because of scarcity, every society, including individuals, businesses, and governments, we have to answer 3 different questions. We have to look at what will be produced, how will society produce those goods and services, and for whom to produce the goods. Essentially, who gets those goods. Now, we sort of looked at number 3 last week when we looked at the different allocation methods. Today, we're really going to focus on 1 and 2. What is going to be produced and how will those goods and services be produced? So, in order to understand what goods are produced and how to produce them, we need to look at 4 different types of productive resources. The first being human resources, which is the use of people's mental and physical abilities. So, actually using humans, using people to get the job done. Examples of human resources can include construction workers, factory workers, doctors, as well as teachers. So, it's not just people who work in manual labor, aka using their hands, but it's also people who use their their physical abilities as well. The second type of productive resource is capital resources. These are the use of goods that were specifically made in order to make other goods. So anything from tractors, any type of machinery, any type of equipment you might find in a factory. Office and factory buildings themselves are considered capital. Any tools that are needed to make a good. So capital resources are goods that were specifically made in order to make other goods. Natural resources. This is the use of materials that come from are harvested from our natural environment, from the earth itself. Any examples can include any trees, any water, minerals, oil, fossil fuels of any type, as well as any fish or other animals that come from the natural environment. And then finally, the last type of productive resource is known as an entrepreneurial resource, which is a source of financing, such as lines of credit or investment capital, along with knowledge of a particular field, or someone's ability to think creatively as well as be alert to new opportunities. Examples of this could be investing in a startup company or loaning money to a business. Think like Bill Gates, right? The guy who created Microsoft, or Mark Cuban. People who have knowledge of a particular field and are willing to take risks, usually in the forms of investing in a new capital or loaning to a business. Now, as we look at productive resources, we need to understand how does it relate to what producers will then make, which leads us to what's known as the production possibilities curve, also known as the PPC. Now, the production possibilities curve is shown here on this slide. It includes various combinations of goods and services that an economy can produce when all productive resources are fully employed. So the curve that you see here, the orange line, that shows an economy using all of its available resources to produce different combinations of goods and services. So to hit this idea home, we're going to look at an example of apples and carrots. On Schoology, there's a PDF file called Apples and Carrots that you can complete as we go along if you want to. It's not required, but it might be good practice. So we're going to look at the production of both apples and carrots, our 2 goods. And we're going to say that we have 3 human resources, aka 3 workers, to start off producing these goods. So as we look at where carrots are grown, can everyone pick up the same amount of carrots? We are going to say yes. Everyone has the ability to bend over and pull carrots from the ground. Apples, however, it's going to be a little bit different. As you can see, apples are grown on trees, and depending on the types of apples, types of trees, usually, generally speaking, if you're taller, you're able to pick up more apples. So we're going to assume our first worker can only produce 1 carrot and 1 apple. Our second worker can do 1 carrot and 3 apples. And our third worker can pick 1 carrot and 5 apples. So essentially, our first worker is pretty short, they can only reach 1 apple, while our third worker is tall and can collect 5 apples. So we have 3 workers, we have 3 human resources. However, we're going to assume that each worker, each individual worker, can only pick carrots or apples in a day, not both. So they have to choose which of those goods they are actually going to produce. They cannot do both. So, what is the maximum amount of carrots they could pull in one day? If all 3 individual workers decide to pull carrots, it would be 3. Because remember, we're assuming each of them can pick 1 carrot a day. And then when it comes to apples, it's going to be 9. Remember, worker 1 could only pick 1 apple, worker 2 could pick 3 apples, and worker 3 could pick 5 apples. So we're going to look at this now and create our own PPC. So, maximum amount of apples that could be pulled if you pull 1 carrot. So as we see here, if all the workers just pulled apples in one day, they would produce 9 apples and 0 carrots. Okay. But if we took 1 worker away from apples and that 1 worker produced carrots, as you can see, carrots are on the x-axis down here, number of apples are on the y-axis, you would get 8 apples in a day. Now, what if we took another worker away? Let's say 2 out of the 3 workers, workers 1 and 2, are pulling carrots instead of apples. Then we would only have 5 apples that would be produced on a day, as you can see as referenced by this dot on the graph here. So this is showing our production possibilities curve based on the numbers we had in the last couple of slides, based on the 3 workers and their ability to pull carrots as well as their ability to pull apples. But how do we increase our production, aka how do we take this curve here and move it up, or move it to the right, if you will? There's 2 different ways to do that. We can either increase our resources, aka increase workers, or increase our productivity. We're going to start with increasing productivity. So there's a couple of different ways to increase productivity. The first one would be to teach your workers how to jump higher so that they can reach 1 more apple or apples, or try to improve their capital, aka give them a tool that they could use to reach more apples, aka something like ladders. So now that we're increasing productivity, either by teaching them to jump higher or giving them ladders, the first worker can now reach 2 apples, the second worker can now reach 4 apples, and the third worker can reach 6 apples. So the total amount of apples that they could pull in one day, if they're all only pulling apples, would be 12. The carrot amount still stays the same. Now this number is graphed here, so you can see it moved up. Instead of 9 like we saw in the previous graph, the total number of apples went to 12. Now if we take, again, 1 worker away to pull carrots, okay, take them away, that loses 2 apples, so then we're down to 10. Then if we take the second worker away, we lose 4 more apples. So if we took 2 workers away to pull carrots instead of apples, they could only produce 6 carrots instead of 10 or instead of 12. And again, if all the workers decided to pull no apples and only pull carrots, they could pull 3 carrots in a day and obviously 0 apples. Now we're going to try to see what the graph looks like when we increase our resources. So we're going to add 1 more worker. Instead of 3 workers, instead of 3 human resources, we will now have 4 human resources. They can also pull 1 carrot, but we're going to say they can pull 2 apples. So the maximum amount of carrots that are possible to pull in one day now are 4, because remember, you have 4 workers instead of 3, with each worker being able to produce 1 carrot. And then the maximum amount of apples that are possible now would be 11, with worker 1 being able to produce 1, so on and so forth. Okay. And now we see these new numbers graphed here that also increase the production curve to the right, with the maximum amount of apples being 11 If we take one worker away to pull carrots, you could only produce 10 apples. If we take another worker away to pull carrots, it goes down to 8 apples. If we take 3 workers away to produce carrots, you only get 5 apples. And if everyone is only focused on carrots, you would get 4 carrots in a day and 0 apples. So again, this is putting all 3 of those different graphs together. This first graph here, if you can see my cursor moving along, the one furthest to the left, that was our red graph that we did first. Okay, so to increase our productivity, we could provide training to workers, either teaching them how to jump or providing capital to them, more capital, giving them a ladder. We could also increase the number of resources. Instead of having only 3 workers, we could increase it to 4 or 5, maybe even 6. So the increase in productivity is this dotted line right here. That was our blue line that we did in the second graph. That increased our productivity. So you can see that it moved from the left a little bit to the right, increasing our productivity. And then we also increased our resources, this furthest line out here, highlighted in green. This is what happened when we added one more worker. So as we look at these different points on each of these PPC curves, as long as a business is working at one of those points, they are working most efficiently. They are using their resources to the best possible way. They're not being wasteful, and they're not trying to do more than what their resources allow them to do. Now, if you'll remember from our discussion last week on opportunity cost, this curve demonstrates opportunity cost in a couple of different ways. So remember, we have 2 different goods on the production possibilities curve. On our x-axis, we had carrots, and on our y-axis, we had apples. Now, if we look at all 3 of these points on this production possibilities curve, as long as producers are working and using they are maximizing their resources to the fullest extent, if they are falling anywhere on the curve, they are working at 100% efficiency. Producers can use this graph to decide what their best use of resources are. But when it comes to opportunity cost, they can also use this to measure their trade-offs. Let's say they are working at point A on this graph. If you are deciding to produce more of good Y, aka more apples, you are losing out on more carrots. But then the opposite can happen as well. Let's say they decide to work at point C instead. So by producing more carrots, more of good X here, they are losing out on more of good Y, aka more apples. So this is going back to the idea of opportunity cost. When you produce more carrots, you are losing out on apples. And when you produce more apples, your opportunity cost is in carrots. So not only can we use this graph to make sure that our resources are maximized, but we can also use it to measure any trade-offs that are happening. Now you see points A, B, and C, like I mentioned before. As long as producers are working to points on the actual curve of A, B, and C, they are working at 100% efficiency. They are maximizing their resources. However, if they are only working at point M, that means they're being wasteful. They have resources, they have capital that they are choosing not to use. So they are working at less than 100% efficiency here at point M. Now at point N, it would be hard to do. They are trying to be more productive than their resources allow for. So that would be producers trying to attempt to work at more than 100% efficiency. So this is the production possibilities curve, which looks at taking in the different types of resources that are available in societies and how can societies best produce different combinations of goods while making sure that they're using their resources effectively. So to help hit this idea home, on Schoology, there is a quiz called PPC Quiz that is worth formative points. You should complete that at some point today. And just another reminder, if you haven't already completed the Scarcity Forum in Schoology, make sure you put a post to that tonight. Both of these are due today. For the Scarcity Forum, make sure you're looking at the rubric and look at the example post that I gave you. Again, if you have any questions, I'll be in my WebEx room today during class time.